Yes, let us see this example on Fourier expansion. We have to find the Fourier expansion or the Fourier series for the function f of x is equal to x in the interval 0 less than equal to x less than equal to 2 pi, given that f of x plus 2 pi is equal to f of x. Now see here, it is given that f of x plus 2 pi is equal to f of x. This just means that f of x is a periodic function with period 2 pi. That means the value of that function f of x is going to repeat after an interval of 2 pi. So this 2 pi is the period of that function. Now see here, f of x is given as x in the interval 0 comma 2 pi. Now when the interval is 0 to 2 pi, we know that we don't have to check whether the function is even or odd. Remember, whenever the interval starts from 0, we do not check whether the function is even or odd. Directly we find a0, an, bn using the respective formula and substitute the values in the formula of Fourier series. Now first of all, to find a0, we know that the formula to find a0 is, for this interval 0 to 2 pi, the formula is 1 upon pi integration with limit 0 to 2 pi into f of x dx. This is the formula that we have to find a0. Now in our case, f of x is x, so substitute f of x as x in this formula. A0 will be 1 upon pi integration 0 to 2 pi. F of x will substitute as x dx. We know that integration of x dx is x square upon 2, and this is within the limit 0 to 2 pi. So remember, in general we know that integration of x dx is x square upon 2, or in general we know integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1. We know it is x raised to n plus 1 upon n plus 1. So in this case it is x raised to 1, so it becomes x square by 2. Now we can take this to outside, so it will be 1 upon 2 pi into integration into say x square within the limit 0 to 2 pi. We know here the limits of the integration are 0 to 2 pi. 0 is the lower limit, 2 pi is the upper limit. We first put the upper limit. So in place of x, we'll put the upper limit 2 pi. So it will be square of 2 pi. It is 2 pi square minus square of 0. Upper limit minus lower limit. So it is 1 upon 2 pi into bracket 4 pi square minus 0. That will be 4 pi square simply. And that 4 pi square into 1 upon 2 pi will be 4 pi square upon 2 pi. So we get a0 is equal to 2 pi. The value of a0, the first term, we have got it as 2 pi. Now once we have got a0, we will find an. We know that the formula to find an is equal to 1 upon pi integration with limit 0 to 2 pi of x into cos of nx dx. See, we know this is the formula to find an when f of x is defined in the interval 0 to 2 pi. Again, we know that our f of x in this problem is x. Substituting that, we'll get this as 1 upon pi. Outside the integration as it is, we'll write it is integration with limit 0 to 2 pi. If you substitute f of x as x, this will be x into cos of nx dx. Now to solve this integration, we'll use the shortcut formula of integration by parts. So we know that integration uv dx can be written as u into v1 minus u dash into v2 plus u double dash into v3 minus dot dot dot. Remember, according to the rule of Light or Eilert, this x we know is the algebraic term, it will come first, and cos nx is a trigonometric term, it will come after the algebraic term. So here in this case, according to this order, we know that the function which comes first should be taken as u. So here we should take u is equal to x and v is equal to cos of nx. So it is integration of u into v form, where u is x, v is cos nx. And remember, the shortcut formula by parts can be used only when u is algebraic. Use some term like x, x square, 1 plus x, 1 minus x. So basically we can apply this formula when u is some term. If we go on differentiating, which will become 0 after some iteration. So here u is x. We know that in this formula dash represents derivative. U dash is the derivative of u double dash is the derivative of u dash, and so on. Suffix represents integration. V1 is the integration of v, V2 is the integration of V1, and so on. So u dash is, say, the derivative of u. So it is, in this case, it is derivative of x, which is 1. So u dash is 1. Therefore, u double dash will be 0. U dash is the derivative of x, which is 1. U double dash is the derivative of u dash, which is 0 in this case. Since u double dash is 0, we need not find v3. We'll have to find only v1 and v2, only because only u and u dash is existing. U double dash, u triple dash, all higher order derivatives will be 0. Now v1 is the integration of v. V1 is integration of cos of nx dx. So it is integration of cos nx, we know, is sine of nx upon n. Remember, in general, the formula integration of cos ax dx is sine of ax upon a. This is the formula that we have. So using this, we can find v1. Here in our case, in place of a, it was n. So integration of cos nx becomes sine nx upon n. So v1, remember, is the integration of v. v2 is the integration of v1. So v2 is integration of sine of nx upon n dx. This 1 upon n being constant, we can take it outside. It will be integration of sine nx dx. Also remember, integration of sine ax dx, remember, is minus cos ax upon a. Integration of sine x is minus cos x, and integration of sine ax is equal to minus cos ax upon a. So here, if you apply that formula, integration of sine nx will become minus cos of nx upon n. So therefore, we get v2 is equal to this 1 into minus cos nx will become minus cos of nx, and this n into n will be n square. So we have found out v1, we have found out v2. There is no need of finding v3 because u double dash is 0. U double dash and all higher order derivatives are 0. So now, since we have got this v, see this part in exam we can do it orally also, but I am showing this in details for our understanding. So now, if we apply this formula here, let me apply it on the next page. Okay, so remember, we are finding the value of the integration with limit 0 to 2 pi x into cos of nx dx. So see, this 1 upon pi will write outside the integration as it is. For x into cos nx, we are applying u into v formula. First we write u, that is x, into, it is u into v1. v1 is sine nx upon n, minus u dash, derivative of x is 1, into v2. v2 is the integration of v1, which already we have found out as minus cos nx upon n square. So see, it is u into v1 minus u dash into v2 plus u double dash into v3. Sorry, we know that u double dash is 0. So next terms will not come there. And this is within the limit 0 to 2 pi. First we'll simplify before we substitute the limits. Let us simplify this. So it is 1 upon pi as it is. It will be x into sine of nx upon n. This minus into minus will be plus, 1 into cos of nx will be cos of nx upon this n square as it is, and that is within the limit 0 to 2 pi. Correct. So now we'll put the limits. First we'll put the upper limit 2 pi in place of x. Remember, we have performed the integration with respect to x. So the limits will be substituted in place of x. First we put the upper limit 2 pi in place of x. If you put 2 pi in place of x, see, this will be 2 pi into sine of n into 2 pi. That will be sine of 2n pi. Similarly here, if I put x is 2 pi, this will be cos of n into 2 pi, that is cos of 2n pi. That is when you put the upper limit, then minus the lower limit, then wherever there is x, will put 0. So it will be 0 into sine 0 upon n plus cos 0 upon n square. You see, if we do that, it will be c 1 upon pi as it is. First I am substituting 2 pi in place of x. So it is 2 pi into sine of 2n pi, this whole term divided by n, plus cos of 2n pi upon n square. This is when you put the upper limit, minus when you put the lower limit 0. 0 into sine of 0 will be 0. If I put x is 0, now I am substituting the lower limit in place of x. 0 into sine of 0 will be 0. 0 upon n will be 0. So I am writing it 0 directly, plus cos 0 upon n square. So see, we got this first bracket when you put the upper limit, and then the second bracket when we put the lower limit in place of x. Always remember, it is upper limit minus the lower limit. Now we know this standard values of sine of 2n pi is 0, cos 2n pi is 1, sine 0 is 0, and cos 0 is 1. Substituting these respective values, we know in Fourier series n is some integer. So for any integer value of n, sine 2n pi is 0, cos 2n pi is 1. Substituting the respective values, we will get an is equal to, this sine 2n pi term is going to be 0. This first term will be 0. Cos 2n pi is 1, so plus 1 upon n square. This minus into 0 will be 0, and minus into plus will be minus. Cos 0 is 1, so 1 upon n square. Plus 1 upon n square minus 1 upon n square gets cancelled, and we get an is equal to 0. So see, after applying the formula of integration by parts, integration uv, we put the limits, upper limit 2 pi minus the lower limit 0, and simplify. After simplifying, we are getting an as 0. Now we have to find bn. We know the formula to find bn is 1 upon pi integration 0 to 2 pi f of x into sine of nx dx. Remember, this is the formula to find bn for a function f of x which is defined in the interval 0 to 2 pi. Yes, so bn will be 1 upon pi integration 0 to 2 pi x into sine nx dx. We substitute the value of f of x as x. And now, so see, again here, if you consider this x into sine nx, it is in the form u into v. So according to the rule of Light or Euclid, this x is algebraic term, sine nx is trigonometric term. We know according to this order, whatever function comes first, that we have to take as u. So u is x in this case, v is sine of nx, v is sine nx. So u dash, that is the derivative of x, will be 1. U double dash, that is the derivative of u dash, that is the derivative of 1, will be 0. U double dash is 0. So we don't have to find u double dash is 0. So u triple dash and all other higher order derivatives will be 0. We'll find v1. v1 is integration of v. So it is integration of sine of nx dx, which will be minus cos of nx upon n. Remember, integration of sine ax is minus cos x upon a. And v2 remember is integration of v1, that is the integration of minus cos of nx upon n dx. Minus 1 upon n can be taken outside, it will be integration of cos nx dx, which will be minus 1 upon n into integration of cos nx is sine nx upon n. So that becomes minus sine of nx upon this n into n becomes n square. See, this part can be done orally also, but I am just showing you this in details for understanding purpose. Now we know for this term bn, we are going to apply the formula of integration uv dx, the shortcut formula of integration by parts, which is u into v1 minus u dash into v2 plus u double dash into v3 minus dot dot. Remember, this formula can be used only when u is algebraic. Use such a term that if you go on differentiating, it will become 0 after few derivatives. Otherwise, this will become a never-ending formula. Correct? So this should be applied only when u is algebraic. Now, yes. So see, bn now is 1 upon pi. We'll keep it outside as it is. If you apply the formula of u into v to this term, see, first of all, u as it is into v1. v1 is minus cos nx upon n minus u dash is 1, u dash into v2 is minus sine of nx upon n square, and this is within the limit 0 to 2 pi whole term. So u is x, u dash is 1, u double dash is 0. So this term u double dash into v3, all remaining terms become 0 because all other higher order derivatives are 0. Now if we just simplify this, first of all, this minus 1 into, or say minus into plus will become minus here. It will be x into cos of nx divided by n, minus into minus will be plus here into sine of nx upon n square, and this entire term is within the limit 0 to 2 pi. First, if you put the upper limit 2 pi in place of x, so wherever there is x here, we'll put the upper limit 2 pi. So it will become minus 2 pi into cos 2n pi upon n plus sine of 2n pi upon n square. In place of x, if you write 2 pi into n will become 2n pi minus the lower limit. Then if you put 0 in place of x, 0 into cos 0 will become 0, sine 0 is 0. So see, if you put the limits, first if you put the upper limit 2 pi, it is 2 pi into cos of 2n pi. I'm replacing x by 2 pi, so it is 2 pi into n, or 2n pi you can say, upon n plus sine of n into 2 pi, sine of n into 2 pi, or you can write sine 2n pi. This whole term divided by n square. This is when you put the upper limit 2 pi in place of x minus, now the lower limit 0 will put in place of x. 0 into cos 0 is going to be 0. So 0 upon n is 0, and here it will be sine of 0 upon n square, which you can also write again 0 directly. Sine 0 is 0. So now if you substitute the respective values, so if we substitute the respective values or the respective limits in place of x, now we'll put the respective value. Cos 2n pi is 1, sine 2n pi is 0, sine 0 is 0. So see, if you put the respective values, this will be 1 upon pi as it is, and inside the brackets this will be minus 2 pi into 1 upon n. This sine 2n pi term becomes 0, sine 0 term becomes 0. The remaining terms are going to become 0. Remember, sine 2n pi is 0, sine 0 is 0. So these two terms will be 0. Only this term will remain. And again in that I will substitute cos 2n pi as 1. So if you multiply 1 upon pi inside this bracket, that pi gets cancelled. We get bn as minus 2 upon n. So see, we'll get bn as minus 2 upon n. Let us check whether it is correct. Yes, it has to be correct. Bn is minus 2 by n is correct. And yes, we know the formula for Fourier series. Fourier series or Fourier expansion is given by, so see, Fourier series for a function f of x in the interval 0 to 2 pi is given by f of x is equal to 1 upon 2 into a0 plus summation n is 1 to infinity an cos of nx plus bn sine of nx. Now this 1 upon 2 will write as it is a0. The value of a0 that we had found out was 2 pi. It will be half into 2 pi plus summation n is 1 to infinity an into cos nx. An was 0. We had found out the value of an. We had got it as 0. Bn we have got as minus 2 upon n into sine nx. See, we know that this is the formula to find Fourier series or Fourier expansion. Already we had found out a0 and bn. We just substitute the respective values of a0, an, bn in this. See, it comes out as pi. This 2 gets cancelled, pi. So this 0 into cos of nx will become 0. And if I take this minus outside, this you can even take 2 outside summation side. So it will be minus 2 into summation n is 1 to infinity, sine of nx upon n as our answer. And again, we know that in this question f of x was x, we can substitute the value of f of x also as x. So see, this is our required Fourier series. We substitute the value of f of x as x, a0 as 2 pi, an as 0, bn as minus 2 upon n in this formula and simplify. This is the required Fourier expansion. This will be our final answer.